Okay, guys, my name is Desmond, and I welcome you to my lesson for today, which is part 2 of the masterclass looking at functions. So, good people, just make sure that before you catch up on this lesson, you've watched part 1 of this masterclass where we are looking at functions. So, ladies and gentlemen, please do allow me to say it's very much important that I say it's very, very much important, ladies and gentlemen, because what I'm about to say, it's massively important. So, guys, a day without learning something new, it's a day wasted. By so saying, please make sure that by the end of each and every lesson that I conduct, you learn something new. So, guys, just an indication, are you all able to see over there? And again, can you all hear me? And just make sure to have your mics muted after you comment. How are you guys doing over there?
We are good and we can hear you clearly, sir.
Last one to confirm. Okay, I suppose all is clear from your side. So let me just check. Tisetso Madikisa, I'm going to mute him. Let me see who has got their mics unmuted. Okay, guys, I notice all of you have got your mics muted. So without any waste of time, let's get to the business of the day. So good people, on yesterday's lesson, we looked at a straight line. And again, we included parabola as part of our yesterday's lesson, which forms part 1 of masterclass. So in today's lesson, I want us to look at hyperbola, and possibly, if we still have some enough time, we'll also look at exponential graph. So obviously, it seems like starting from tomorrow, that's when we'll be solving exam type of questions, of which I so wish that all of you guys can make it to my lesson for tomorrow. So, ladies and gentlemen, what I'm going to do now is just to remove this so that we focus on what is it? The first function for today. So let me see. It seems like someone has got their mics unmuted. Mabuntle, I'm going to just mute their mic. So guys, please make sure that your mics remain muted. Okay, so ladies and gentlemen, hyperbola, it's a function. So let's consider this to be the third function that we're looking at. So remember, guys, when I started yesterday's lesson, I indicated that a human being goes through phases. Initially, you start as a baby. Then from there, let's just say here you are as a baby. Then you develop to become a teenager. So let's say teenager over there. From being a teenager, let's consider you as an adult. So guys, just make sure that you've got your mics muted. So just in case if you just joined the lesson now, just make sure that you've got your mics muted. I'm just not sure if you guys are aware that if I mute your mic from my side, you will never be able to communicate until the end of this lesson. I see Kitumetse there. It's got their mics unmuted. So I'll just mute it from my side. Ladies and gentlemen, let's now have a look at a function called hyperbola. Let's see. Hyperbola. So, how do you notice that a function is a hyperbola? This is where the function started, guys. It's y is equals to a over x. The moment you see this, then you know you've got a function called a hyperbola. Remember, guys, you need to be able to differentiate between all these types of functions. Yesterday, we spoke about a straight line, which we said it's actually y is equals to mx plus c. And then we also looked at a hyperbola, which we said it's a to the exponent that then we said this is a hyperbola. So we said this has got that invisible of a positive 1 as a power, and this one has got a power of 2 or squared, which makes it a parabola, and that being a straight line. So in this case, can you see you've got a over x, y being equals to that. So can you see there is a distinct, there's a huge difference in all of this formula. So it's easy to notice which one is which. So you just need to be aware that you attend such lessons so that you are aware of the different types of functions you've got. So remember, guys, let's consider this as the beginning, ladies and gentlemen, as the beginning of a hyperbola. So it grows or it develops to become a teenager. Let's have a look at how it looks like as a teenager. So we've got y being equals to a over x plus, let's say, p. So for someone who's in grade 10, you might find that you focus more on this type, and maybe after June you might find that you're looking at something similar to that, or possibly in grade 11 you might be looking at something similar to that. When you get to grade 12, it gets even more complicated. Not really complicated, it just looks complicated, but we are going to just unpack it in this lesson. So the difference there is that you've got plus q. So here you've got y, it's equals to a over x. You've got y is equals to a over x plus p. That is the difference. Then you've got y, it's equals to a over x plus p. Then you have q over there. So for you to fully understand what happens over there, ladies and gentlemen, that's when we try to have a look at these letters. We know x is the independent value and y depends on x, which means when x is 1, y value it's going to be a certain value. When x is 2, when x is 3, 4, 5, or a negative value or 0, the y value will depend on the x value. But now, what is the impact of that a? Or what is the effect of that a on a hyperbola? So let's quickly have a look at the effects of a on that function. So Kulu something, can you please have your mic muted? I'll just mute it from my side, guys, so that we smoothly run with our lesson. So the effects or the effect of a, it's what I want us to make sure that we have a look at before we even go far. So let's have a look, guys. When we have that a being greater than 0, what does it mean? Every time when they say something and they use that sign being greater than 0, it simply means it's a positive something. When you've got something, ladies and gentlemen, when you've got something being less than 0, that means you've got negative something. Let's say in this case that something is A. So that means A can be maybe positive 1, or it could be positive 9, or it could be 8, or it could be 80. For as long as it's a positive value, it means it's greater than 0. We know from our number line that is 0 in the middle, then you have negative values there, you have positive values there. So on this side, we have positive A values. So you can see from there in that direction, A values are greater than 0. From there in that direction, we have negative A values, which are less than 0. So I hope it makes perfect sense. Something quickly to blow your mind, guys. I know there are some of you who might be confused in terms of between these two inequality signs. Which one is greater than and which one is less than? So, ladies and gentlemen, I'm just going to take you through a very quick exercise. You don't need to comment on this one, guys. This is my right hand that I'm using to write. So I want you guys to do something. So just do something similar to this with your right hand, and again do the same like that with your left hand. I hope you guys are able to see the shape that I'm trying to make over there. Just do that. So that means you've got your fist and you have your elbow like that for your right hand. Then you've got let's say this is your fist, and then you have your elbow for your left hand. So you do something similar to that. I hope you guys are able to see what I'm trying to say. So here comes a question, guys. For those who are right-handed, you don't need to answer. I'll answer the question because I'm right-handed. Can you see? This is my right hand with that shape. Between my right hand side and my left hand side, which one has got more energy or is greater in energy? Guys, my right hand side has got greater energy than my left hand side, which means my left hand side has got less energy. That is the reason why when I was in grade 10 up to date, I never forgot that a sign similar to this, which is my right hand side, it looks like that one, which means always, 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 this sign will always mean greater than, because my right hand side is greater in energy. And this sign, which can be done with my left hand, it means it is less than. So what they can add is that equal sign over there, then it becomes greater than or equals to, less than or equals to. So I hope you guys now understand and you are able to notice the difference between the two. So let's get to the business of the day before we forget what we were explaining. So where A is greater than 0, ladies and gentlemen, our graph will fall, or it lies in the first and fourth quadrant. Graph lies in the first and fourth quadrant. So remember, guys, you might not be able to listen and write and watch on your screen at the same time. So remember, this lesson is being recorded. So just in case if there's something that you couldn't write, you can still be able to catch up. So my advice to you guys is that in case if it's cold and you've got your blankets and whatever, don't stress that much about having to write everything that I'm writing. You can just listen and watch. So you will write your notes whenever you catch up. So I'll just give an example of that, Mr. D. So that means on a Cartesian plane, if we have our function being y is equals to, let's say, positive a value over x, that positive a value, it could be, for example, y is equals to maybe 3 over x. Because it's a number over x, then this is a hyperbola. So most importantly, the a value, if it's positive, it means the shape of my hyperbola is going to be something similar to that. So I'm not really that much concerned about the shape or whatever. I just want you guys to be aware that the parabola will be in the first quadrant and the let's see, I just want to confirm something over there, guys. This is 1, 2, 3, 4. So let's see. This is going to be, I just want to make sure that by first and fourth, I might need to correct something there. This is quadrant number 1. This is quadrant number 2. This is quadrant number 3. And this is quadrant number 4. So exactly how I drew it, that's how it is supposed to look like, which means there it's actually third quadrant. So that means if A is positive, you are going to have your hyperbola in the first quadrant and the third quadrant. I hope that makes sense, guys. Which means the opposite, obviously, it's going to be a negative a over x being y is equals to. So let's say we had our hyperbola with a negative a value, which means there you are going to have your hyperbola in the second quadrant and again in the fourth quadrant. So that means in addition to that first note regarding the effect of A on a hyperbola, you are going to say when A is less than 0, remember, obviously anything less than 0, it means it's negative. So when A is less than 0, then you say the graph lies in second and fourth quadrant. I hope that makes perfect sense, ladies and gentlemen. So another thing which is very, very much important, guys, we have what we call asymptotes. Let's see. We have asymptotes. So every time when we talk about a hyperbola, Nduna, always you must remember that we have what we call an asymptote. So asymptote is more like a special Cartesian plane for a hyperbola. I'll just give you an example, guys. Obviously, we have the y-axis and the x-axis. Let's say, for example, we have that hyperbola and we also have that hyperbola there. So this could be a function of, let's say, h of x, f of x, or whatever. So what are the asymptotes? An asymptote, guys, it is that broken line where your function will run closer to, but it never touches. So that means in this case, where you have, for example, y is equals to a over x as a hyperbola, obviously it's going to be positive a. Why positive a? Because the function lies in the first and the third quadrant. That means your asymptotes are within the x and the y axis. So within this you have broken lines. So it seems like a solid line because you have your asymptotes and again you have your axis. So That means if you are given this function, let me just give it a number there, which is going to be a positive number. So let's say this is a positive 3 over x. If a question says, what are the asymptotes of this function? You simply say x is equals to 0 and y is equals to 0. Why? Because for the asymptote of y, you can see it's actually passing through the origin. Again, for that one of x, it passes within the origin. That is why you say x is equals to 0, and again y is equals to 0. So if this function, for some reason, it shifts by 2 units to the left and again by 2 units upwards. So that means that function, let's say it is going to be something similar to that. This is just an example, guys, because it has shifted up and again to the right. As it shifts, guys, even the asymptotes shift with the function. So that means your asymptotes will now be somewhere there for the x asymptote, and for the y asymptote, let's see, it is going to be somewhere there. So that means this hyperbola, it will just run closer to your asymptotes and it will never touch or cross the asymptote on both sides. Even on this side, it will just run closer to both of these asymptotes, but it will never touch or cross. So that means that one, it is just going to run closer to that asymptote, which means always when you sketch your hyperbola, it's very much important that you start with your asymptotes. Then afterwards you can plot the points. So let's now discuss again to explore the effects of A. I think for now, we've discussed all that we needed to discuss with regards to the effect of A, ladies and gentlemen. So now, I think what we can discuss is that function at that stage. So I think at a teenager stage, obviously there's something added to the original function, which is p. We notice there we've got p, which means, ladies and gentlemen, the effect of p, let's have a look at this. We have the x and the y axis. So this is the x-axis, this is the y-axis. Let's say for some reason we have a function which is y, it's equals to negative 4 over, let's say, x, let's say plus 2, for example. Or maybe in the meantime, let me just use that p over there so that I explain the impact of p. So obviously, guys, because a is negative 4, or it's a negative value, we know the original position of that function is actually in quadrant number 2 and again in quadrant number 4. Very, very much important, ladies and gentlemen. So now the effect of that p, guys, this is the x asymptote. Very, very much important, guys. This is the x asymptote, which means if x is positive 1, then the asymptote is the opposite sign of that number. For example, if maybe there, let's say, is positive 8, that means the asymptote is actually negative 8. If, let's say, there is x maybe a minus 18, that means the asymptote is going to be positive 18. So in short, it's more like you just take the whole of that, you equate it to 0, you transpose, then you have your x asymptote, which means, let's say, for example, we have a positive 2 over there. The first thing that you need to be aware of is that the a value is negative, which means the function is going to be in quadrant 2 and quadrant 4. And secondly, you have your asymptote being positive 2, which means the asymptote is actually negative 2. The x asymptote is negative 2. So you have, let's say, negative 1, negative 2, 1, 2. So you firstly start with your asymptote, which is a broken line at negative 2, at where x is equals to negative 2. That is your asymptote. So obviously, because your function is in the second quadrant, then you are going to have something similar to that. Remember, guys, it's just a function which runs closer to that x-axis and again closer to that vertical asymptote. Remember, guys, in addition to that, we have the vertical and the horizontal asymptote. You can add that as part of your notes. So that means this is the vertical asymptote. Where is the horizontal asymptote? In this case, for this function, the horizontal asymptote is within the x-axis. So that is the horizontal asymptote within the x-axis, which means, remember, guys, now you have to draw that function in the fourth quadrant. So here it's something interesting, guys. You remember, originally, this function was going to be somewhere there if we did not have that 2. So it's more like this 2. It actually shifts that function by 2 units to the left. So that means if that function was passing somewhere at that point, it now shifts negative 1, negative 2. So that means that function now is going to actually run like that. I'm not sure if you guys understand that. But remember, guys, this is just for the sake of me explaining the notes. So I'm still going to be giving you guys some examples of which we will explore those examples until it makes perfect sense. So the last thing that I want to comment on this function is that if a question comes there and they say, what are the asymptotes? You will therefore say, let's see, for the x asymptote is x is equals to, it is that with the opposite sign. So it's actually negative 2, which is that broken line over there, which is the vertical asymptote. So for the horizontal asymptote, you're going to say y is equals to, can you see? It is within the x-axis. I hope that makes perfect sense, ladies and gentlemen. So now let's have a look at a parabola at that adult face. So I'm just going to quickly remove all of this. So just make sure that everything that I write over there, guys, it makes sense. It might not make sense now, but one thing for sure, whenever you catch up on this lesson, it will make perfect sense. So we said we have the asymptotes, or what we call the asymptotes when we're dealing with a hyperbola. And again, we have the vertical and the horizontal asymptote. So let's assume that we have dealt with the grade 10 stuff, where we look at a function being a with a positive value or negative value. We have discussed that, and I suppose it made perfect sense to everyone. So let's get to teenage stage, where we are looking at, let's say this is a grade 10 staff, let's say this is a grade 11 staff. We are now looking at grade 12 staff. But just to recap, we also said Positive and negative is still the same thing. But in this case, the only difference is that we have P being added over there. So that P, because it's X plus P, it therefore talks about the what is it? The horizontal, or maybe this is the vertical, actually, it's the vertical axis. So that means it tells us where the asymptote cuts the x axis. Or maybe quickly, let me say if we have y, maybe positive a value over, let's say, x plus 7, and again we have y, maybe negative a value, x minus, let's say, 3. And the question says, what is the asymptote of that function and what is the asymptote of that function? Obviously, first thing first, you will say x plus that value there. I think I said it's 7. X is equals to 0. So you equate the whole of this to 0. Then you just say x is equals to, you transpose, which means your x asymptote, it's actually equals to negative 7, or your vertical asymptote, it's negative 7. And again, for this one, you just equate that to 0, which means you have x minus 3, it's equals to 0, x is equals to, you transpose, it becomes positive 3, which means for this function, your asymptote or your vertical asymptote is equals to 3. Can you see? The asymptote, it has got nothing to do with the a value being a positive or negative. You just need to know that on your Cartesian plane, this is your y-axis, this is your x-axis. So for this one, your asymptote is on this side, negative 1, 2, 3, 4, 5, 6, 7. So it's on this side of negative 7, which means the broken line will be there. Then if your function is positive, then you are going to have your function like that, and also on that other quadrant. If your a value is negative, you are going to have your hyperbola there and also there. I hope that makes perfect sense. And again, the asymptote for y, it's y is equals to 0 for both functions. Y is equals to 0. Something that might be confusing you is that, how do I notice that my asymptote, my horizontal asymptote, is actually 0 and is running within that axis? This is something that I'm going to answer, guys, of which at all times make sure that what doesn't make sense, it ends up making sense, because these things, ladies and gentlemen, they are not really that much complicated. Everything has got its own explanation, and again, there's a reason for everything to form part of the formula. Very, very much important, ladies and gentlemen. So now let's have a look at that formula there at an adult stage. So ladies and gentlemen, you can see the only difference there is that Q value. So the Q value, it obviously has an impact on the vertical shift. So when we talk about the Q value, guys, I think I'll also explain that in depth, but for now, allow me to say it actually has an impact on the vertical shift. I had to say the vertical shift. Remember, when we talk about the vertical shift, it doesn't necessarily mean that upward. It means it can be shifted up or down. Very, very much importantly. So, which means if we have, let's say, y, it's equals to, let's say, a positive 2 over x, let's say, minus 1, and let's say plus 2 over there. Can you see now? This Q value, again, guys, it is now the y, or maybe let me say, this is the horizontal asymptote. So if a question comes and say, what are the asymptotes of this? Then you say x, you say minus 1 is equals to 0. Just take it as it is, you equate it to 0, which means x is equals to positive 1. And the y asymptote is this one. You take it as it is with its sign, which means if it was -3, you take it as -3. In this case, it's +2, which means it's 2. What does it mean, ladies and gentlemen? It means on your Cartesian plane, I said first thing first, start with the asymptotes. Let's see. The first asymptote is x, that's equals to +1. So let me just do that and say maybe we have that. So an asymptote is a broken line at x it's equals to 1. So at x it's equals to 1, that's where we've got our first asymptote. In this case, you can see the asymptote is not running within the x-axis, but it's running at y is equals to 2. So that means this is the y asymptote. So where is 2? This is 1. Let's say this is 2. So this is now the asymptote. Very, very much important, ladies and gentlemen. So this is the asymptote at y is equals to 2. Guys, once you are done with your asymptotes, your vertical and your horizontal asymptote, that's when you say, let's have a look at our a value. Is it positive or is it negative? It's positive. What does it mean when it's positive? It means our hyperbola is going to be in the first and that quadrant. Obviously, it was originally in that quadrant, but there was a shift of asymptotes. So can you see this asymptote it shifted by 1 unit to the right? So that is why even that function it also shifts towards the right by 1 unit. And also guys, in short, everything shifts. So this asymptote, we know that in grade 10 or at that stage, it was actually running within the axis and you had your hyperbola there and there. But because of this and that, there are some shifts. It shifted 1 unit to the right, which means this actually has an influence on the left or right shifts, sideways shifts. And this one being either positive or negative, it has a vertical shift which could be up or down. So, ladies and gentlemen, let's quickly try to explore some of these graphs. So I think I've explained all that I wanted to explain, but remember guys, it doesn't necessarily mean that I've mentioned all that you needed to know. You might find that there's some additional information which you will explore as we solve exam type of questions starting from tomorrow. So just in case if you missed my yesterday's lesson, just make sure that before you attend tomorrow's lesson, you watch that lesson, because I'm sure we might be dealing with a function where we focus on a parabola and a straight line. So you will explore some additional information in the lesson, especially in terms of the domain and the range and so on and so forth. So good people, let me where is my cloth? Guys, someone stole my cloth. Who stole my cloth? Lebohang, where is my cloth? Did you take it or something? I can't find it. Guys, why are you stealing my stuff now? What's going on here? Vathanan, let me see. Ndona, are you there? Are you not the one who stole my cloth? Hi, my daughter. Mr. Tele. Shreyas, is everything good that side? Let me see. Determination, Kemi, Zandile, Lihlumelo Njemla, Tumelo Jennifer, Makazumfukeng, Tebatso Grace, is it Koli Swatele Sisipo? Guys, are you guys okay that side? Is everything clear up to this point? Likeleli, Kolofelo, Changase, Tebazo Grace, or Sisipo, Kevin, Chabia, Kolofelo, Hope, Okay.
Yes, sir.
All right. 100%, guys. Thanks very much for bringing my cloth. I think for now, I can just remove all of that. So I want you guys to pay full attention to what I'll be explaining over there. So here we've got our Cartesian plane. So what is a Cartesian plane? That's when you've got the x and the y axis. Every time when you're given a function, guys, let's say we have a function being y, let's actually give it a name and say this is f of x. I'm sure at this stage you understand that functions are given names. So this one we call it France. Let's say this is France of x, who is 2 over x. So without you having to literally draw that function, guys, you need to ask yourself these questions. The first question is, so you can just write it as part of your steps in plotting a hyperbola, but don't stick to that because it all depends on the information given. So the first thing that you need to ask yourself for this one, at what stage is this function? Is it at a baby stage, teenager, or at an adult stage? Let me see. It seems to be at a baby phase, which means there you can see you don't have plus p, you don't have plus q, which means your x asymptote is equals to 0. So remember, guys, we used to say whatever at the bottom there you equate it to 0. So can you see it's just x which is equals to 0. So in terms of your y asymptote, it's equals to also 0. Why 0? Because there you don't have q. So Shreyas and everyone who's in grade 10, Mr. Tele, when you sketch your function for that hyperbola at a baby face, you firstly start with your asymptotes which are within the x-axis. Obviously, because this is the horizontal one, it means is that one for y. So you also have that one within the y-axis being your x is equals to 0. Then you can say, now that I've got my a being positive, what does it mean? I know that when my a is positive, it means it falls in the first and that quadrant. So let's quickly, we already know these are our asymptotes. I'm just not sure if you guys will be able to see over there. So, but remember, guys, this is our function of, let's see, f of x is equals to 2 over x. So let's see what happens where let's say maybe x it's negative 3. So that means you're going to say 2 over x being negative 3. What is the y value there? So fraction button 2 over, you punch negative 3 over there. As a decimal, it's something like 0.3, but a negative, 0.6. So let's just say 0.7. Then you just go and change that and put that being negative 2. So where it's negative 2, you have your y being negative 1. And then let's see there, where x it's negative 1, I'm getting negative 2 over there. And when you put 0 there, I'm sure it's going to give you an error. Can you see? It gives you error. So where you have error, that's where you have your asymptote. So why are you getting error, guys? I will show you shortly why it's giving you error and what does it mean. So now let's substitute 1 there. Obviously, it's going to be 2 divided by 1 is 2. If you substitute 2 there, it's going to be 1. If you substitute 3 there, let me see, you have 2 over 3, which is going to give you a decimal, which is 0.7. So let me quickly try to see if I can plot all of that. So where x let's see, -1, -2, -3, 1, 2, 3, 1, 2, 3, -1, -2, -3. Let me see, where x is 1, y is actually let's see, it's actually 2, so it's that point there. And again, where x is 2, y is 1. So these are the points that I'm trying to plot, guys. You can see there I'm saying where x is all of that, the corresponding y value is that. So this is where I am, where x is 1, y is 2. Where x is 2, y is that. Well, ladies and gentlemen, easy, 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 easy. So where x is 3, this thing is somewhere there being 0.7. So can you see, it already gives you the shape. All you do is just to make sure that your hyperbola runs very close to your asymptote. Very, very close to your asymptote. So you also plot this side and you say where your x is negative 1, you have -2 over there. And again, where x is -2, I hope you are able to see. Where x is -2, what is y? Y is actually -1. So you have something closer there. Where your x it's -3, your y is something like 0. What is it? 0.7, but negative. So already it guides you in terms of the quadrant in which your function is. All you do is just to make sure that you have that shape like that. And most importantly, your hyperbola running closer to your asymptote within that axis. So remember, guys, I said where this is 0, guys, it gives you an error. So that error means your function will never ever cross that 0 line over there. So that is why always your function, it runs very closer to your asymptote. It keeps on getting closer, but it will never touch or never cross. So instead of it being 0, it will never be 0, guys. It can be something like 0,00001 or maybe 0,00000. Guys, you can make zeros from where I am now up to wherever you are. When you get to wherever you are, there must be a number which could be 1 or maybe 2, 3, 4, 5 or 9 or whatever, but it will never be just 0,0 because we know that when we substitute on this function where x is 0, it gives an error, which means there is no hyperbola along that. I hope, ladies and gentlemen, that makes perfect sense in terms of why are we having an error or undefined, and again, why are we having asymptotes. So Mr. D, our teacher, Mr. Mungwezi, he used to say, Kaspedi, guys, ore erapalla le asymptote. I'm not really sure in terms of how to explain that in other languages, guys, but erapalla kore erapalla le yona, guys, it just runs closer, you know, as it continues in that direction. It just keeps on getting closer and closer and closer and closer and closer. It will never ever touch that, and it will never cross. Mr. D erapalla Leo, guys, how do I say that in Venda? Someone who's here in this lesson, somewhere in Venda, and they understand what I'm trying to say. How do I say that in Venda, guys? Is there someone who's in Venda in here? Let me see. I'll just try to look for a Venda name. Where is Mukwevo? Let me see. Mukwevo is not here. Nduna, how do we say Rapalla Leona in Zulu? Mr. Tel, how do we say that? Minentle Dlamini, are you Zulu? Xoliswa. Xoliswa yiXhosa. How do we say it? Determination, Kime, Zandile is also listening. Let me see. Who's got their mics unmuted? I'm not sure if they want to respond to my question. But
can you repeat your question?
So I'm saying, how do you say it in Zulu to say this function will just continue running closer to that asymptote? So in Sepedi we say erapalla leon. That's how my teacher used to say. He used to say erapalla leon. But how do you say it in your language?
Izoqhubeka.
Izoqhubeka.
Yeah, izoqhubeka.
Izoqhubeka.
Which means it will carry on.
No. Izoqhubeka, but duze. It keeps on qubeking duze. Something of, yeah.
It means izosendela in Xhosa.
Oh, izosendela.
Izosondela.
Yes. Izosondela. It keeps on sondeling to that. I hope I said it correctly, guys. Cele, izoqhubeka ize duze, or izoqhubeka. Yay, guys. I hope it makes sense. Shreyas, what we are saying here is that this hyperbola, it just keeps on getting closer and closer and closer and closer. It can continue like this up until it reaches Ukraine. It will just be like this. It will never touch or cross. It will just be like this until it can go again and continue to reach some other continents, but it will just be like this. I hope that makes perfect sense. So, izosondela erapalla le the asymptote. So, let's now try to have a look at a function similar to, let's say, something like let's in this case, let's say we have g of x being equals to, let's say, -3 over let's say x maybe minus 1 there. So can you see, guys, let me not go deep into trying to accurately draw that, but I'm aware that you have noticed how to plot the points. You have to have your line of x values, then you just substitute maybe -4, -3, -2, -1, 0, 1, 2, 3, 4. Then it's going to give you the points of which you make the points, then you plot. So I just want to explain to you generally in terms of how that function will look like. So because the a value is negative, then you're expecting something in these quadrants, first and first. So because of that, it means your asymptote is actually x is equals to, or maybe let me just say x minus 1 is equal to 0, then x is equals to +1, which means you are going to have asymptote there. So in short, what does it mean? Can you see? If you did not have that -1, it means the asymptote was going to be within that vertical y-axis. But because there's -1, then it shifts to the right. There, it's a calculation to show that asymptote is actually 1. So that means this function, which was going to be there and there, it has now shifted to this side. So that means, guys, izosondela. What is the asymptote of y? It's obviously 0. Why? Because there that function is just +0 there. There's no q. That is why it's 0. When it's 0, what does it mean? It means it's within that x-axis. I hope that makes perfect sense, ladies and gentlemen. So that means erapalla leon. If you have to sketch that one, guys, you are going to have something similar to that. So, guys, the reason why I have to emphasize that erapalla leon is because Once you have your thing crossing there or touching each other, just know I won't even bother to give you a half a mark because you did not attend today's lesson when we were discussing that this thing is sondering closer to the asymptote. So also here, guys, it is just sondering closer to this thing, guys, and you are going to have something similar to that. It never touch that asymptote. It is just sondering. It is just rappelling with this thing, guys. I'm just not sure of how to stress this thing, but it's very much important that I stress it because you can easily lose some marks for not plotting it correctly. So now let's have a look at this last function where, let's say, for example, let's say you have y being equals to, let's say, negative 3 over 2 divided by x, let's say maybe plus 2 over there, and then let's say plus 3. Very, very much important, ladies and gentlemen, that in this case, you notice the type of a function that you're dealing with. Is it at a baby stage, teenage stage, or adulthood? So you can see you have that, and you also have that. This is the adult stage, of which you guys in matric, you should know up to this level. Very, very much important, ladies. So let's see. Don't be confused by that fraction over there. You just need to know if it's positive or negative. If it's positive, then it means your function is going to be in the first and the third quadrant. Because it's negative, it's going to be in the second and the fourth quadrant. That is the first thing that you should notice. Second thing, your asymptotes for this one. Obviously, x plus 2 equals to 0, then it means x is equals to negative 2. Then your y is going to be, you just take it as it is with its sign. So if it's positive 3, this is positive 3 of your asymptote. So let's do those asymptotes. We have the first asymptote as at x is equal to negative 3. So I mean negative 2, negative 1, negative 2. So you have your first asymptote there for this function. So you have that one there. Let's see, y is equals to 1, 2, 3. You have another one over there where y is equals to 3, and this one where x is equals to negative 2. Then remember, your a value being negative, it means you are going to have something ya o rapalla, guys, eno rapalla le the asymptote. Guys, I hope it now makes perfect sense. So again, let's see. It means you are just going to have something similar to that, guys. You just draw a function which is actually closer to that. But be careful, guys. Don't just draw something like this without you having to go through those points. So that means for this last function, you are going to have something similar to this. Let me see, is 3 over 2. So you're going to have negative 3 over 2, and what else? It's plus 2, then plus 3. Then you must punch all of this on your calculator by firstly substituting negative 3 there, then you get a number. You substitute negative 2 there, then you get a number. You substitute negative 1, you get a number. And you also check if you substitute 0, it doesn't mean it's going to give you an error when you substitute 0. You might find that it gives you an error maybe when you substitute a negative 2. And again, when you substitute another x value there, you might find that it gives you an error. Whatever the case may be, you just need to be careful of the fact that it doesn't mean always when you substitute 0 there, it gives you an error. Let's maybe quickly try to check which one gives us an error, but I'm already aware of what is going to give us an error. So it is that value whereby when you say that value plus this one, and it gives you 0 at the bottom. Possibly that could be the one giving us 0. So let's see. You start with a fraction button in brackets, negative 3 divided by 2. At the bottom, let's say you have that negative 2, obviously plus 2. On the side, you have minus 3. Can you see? It gives you an error when you have a negative 2. So when you substitute negative 2, that's when it gives you an error. I hope that makes perfect sense. And you know very well that where it gives you an error, that is possibly your asymptote. So just make sure, guys, that you know, it makes sense. And obviously that one is the asymptote where you say y is equals to q being asymptote. Very, very much important, ladies and gentlemen. So guys, that's all that I have
Can't
to
hear
explain
you,
to you
sir.
guys with regards to a hyperbola. So quickly, I think we should try and move to exponential. I'm not sure, Madam Speaker, are you now able to hear me? Because I heard you saying something like you're not able to hear me, but can you hear me now? I suppose you are able to hear me. So let's also go through the same phase. I'm just going to be quick on this one because some of the explanations
I can't
are
hear you. I
almost the
don't know
same.
why.
Let me just check. Shreyas, can you hear me that side?
Yes, sir.
Who else can? Let me just check. Oliswa, can you hear me? Minentle, can you hear me? Nduna?
Yeah.
Remember, guys, sometimes you might be speaking forgetting that you haven't unmuted your mic. If you want to respond, unmute your mic first, comment, then mute it afterwards. So, Likala or whoever, I'm not sure what could be the issue there, but just make sure that you've got your speaker maybe on loudspeaker or try headsets or whatever, but everyone else is able to hear me. So let's see, guys, let's start it at a baby stage, develop it up to a teenage stage, let's say teenager, and then up to an adult. I hope it makes it easy when I explain it like this, guys. So we are now on exponential graph. Exponential graph, ladies and gentlemen. So this is where it starts. It starts as just y being equals to b to the exponent x. This is where it starts. So can you see in this case, the x is the one being the exponent, which makes the function to be an exponential graph. Then it doesn't end there, guys. It doesn't end there. As it develops, it ends up looking something like y being equals to, they now added a over there. Then it grows. Shreyas. Now you are in grade 12 and you might find that it's something looking like that. Obviously, a b to the exponent x as usual plus q. And I'm sure by now you can guess what is the impact of that q value there. These things are easy, guys, and the same. But before we go deeper, guys, let's quickly try to explore what's going on over there. Very, very much important, ladies. So now let's just quickly talk about that function at a baby stage. So something very much important for you to notice is that this b is actually a greater than 0. I'm sure you now understand what is meant by something being greater than 0. And again, the same b cannot be equals to a 1. So you just need to be aware of that. So guys, quickly, when this b value is actually greater than 1. Remember, we said it cannot be equals to 1. So that means it can only be greater than 1 or possibly less than 1, but there might be a range, which means it can still be less than 1, but never less than 0 there. So that means, in short, again, guys, this B can be between 0 and 1, or otherwise it can just be greater than 0. When something is greater than 0, it means it could be 2, 3, 4, 5, or whatever, 1,5 or whatever, guys. So when B is greater than 1, in short, we say we are having an increasing function. So we have increasing function. No need to worry that much about that, but this is just for your information. And the reason why we call it an increasing function is because the y value increase. So the opposite is the truth. That means when this b value is actually between let me just represent it mathematically over there to say, when something is written like this, you have 0, you have less than, you have whatever letter, then you have whatever number. This thing means when this is between this number and that number. So in this case, we are saying when B is between 0 and 1. What numbers are between 0 and 1, guys? It's easy. You have 0, you have 1. There in the middle, you have 1 over 2, which is half. There you can have quarter being 1 over 4. What is it? There you can have, I'm not really sure of what is 75%, or maybe let me just say 0,5. If you want it in decimal, type 0,5. So these are the values which are between 0 and 1. So that is the value that we are talking about over there, to say if this b is something greater than a 1, then we have an increasing function. When b is between 0 and 1, we have a decreasing function. The reason to that is simply because the y value decrease. So this is just for your information, guys. As we continue, we will explore some more. Most importantly, guys, also in this type of a function, we also have the asymptote. So the y asymptote is actually equals to a q. So it's more like, in this case, guys, that q value, you take it as it is. So if we have on a Cartesian plane, this is y, this is x, and maybe let's say we had y is equals to maybe a b to the exponent x, let's say plus 3. So this is 1, 2, 3. Then this is your asymptote. Also here, guys, we just have our function rappelling with that asymptote. So eno rapalla leo is sondela, guys. It just sondela this thing, but it never touches, it never cross that asymptote. I hope that makes sense, guys. And in terms of the domain and the ranges, we just say the domain x is the element of real number, and the range y is greater than 0. It's going to make perfect sense tomorrow as we solve this type of problem. So quickly, guys, I want to explain to you the effects of A. Let's talk about the effects of A. Where is A, guys? This is that A over there. So that means part 1, part 2, I was just explaining that, guys, to say this actually tells us if we have an increasing or a decreasing function. I hope that makes perfect sense, guys. So let's see. Let's now have a look at the impact of A, which is that A over there. In short, guys, A affects the steepness of the graph. What does it mean? If you have to draw your your exponential graph over there, you can have a graph like that. Okay, let's say this is the graph of a G. So again, you can have another one maybe like that. So can you see, guys, if you had to walk from that side, you're walking. Can you see it gets steeper very quickly? But this one, the slope is gentle. So the steepness is actually influenced by that A over there. Very, very much important, ladies and gentlemen. So as part of the notes, let me just write it in a form of a list so that you can have some notes. So A, it actually affects the steepness of the graph. Very, very much important, ladies and gentlemen. And again, the y-intercept is actually A. The y-intercept is actually A. Remember, y-intercept, that's where x is 0, then it's going to be A. I'll give an example. Let's say a function is y is equals to, let's say it's 7 being A, then we have maybe a, what is it? Let's say 2 to the exponent x. Can you see? This is a function which is an exponential one. So the A value is positive 7. The B value is 2. Then you have x over there. So obviously, when you calculate the y-intercept, you say the y-intercept, that's where x is equals to 0. So let's see. When you substitute 0 there, what happens, guys? This is going to be equals to 7 multiplied by 2 to the exponent 0. So try to punch this and let me know if it doesn't give you 7. Let's see. You don't need to comment. I'll just confirm it. 2 to the exponent 0. Can you see? It gives 7. Why 7? Is because anything to the exponent 0 is equals to 1. So it's more like it's A multiplied by 1, which is going to be 7. It doesn't matter whether there inside is 8 or whatever the number could be. For as long as you say to the exponent 0, anything to the exponent 0 is 1. So that means is the A value being multiplied by 1. That is why it will just be the A value. I hope you guys welcome that explanation. So lastly and quickly, guys, let's have a look at what happens if maybe that A is less than 0. So if A is less than 0, obviously for a number or for a letter being less than 0, it means it's a negative number. So that means the graph reflects about the y-axis. So you have a reflection. It reflects about the y-axis. So when we say something reflects about the y-axis, if you had, let's say, a square over there, and we reflect it about the y-axis, it's more like it is now there. When you reflect it, then it comes to this side. So it's going to be this side. So this is a reflection of that about the y-axis. So if you reflect it about maybe the x-axis, so that means it is on that side. You reflect it, then it becomes this side. I hope in terms of the reflection it makes sense. So you might find that if you have maybe your exponential graph like that, think of yourself rotating this or reflecting this about that. You might find that you have the same thing, but then it is now like that. So it's not that much complicated, guys. You just need to be aware that there are some reflections over there. So quickly, I want us to discuss the effect of that Q over there. So let's see. There you are having y is equals to ab to the exponent x. We have discussed that teenage stage, but now there's a plus of q over there. Remember guys, q, it actually has an impact with regards to the vertical shift. What does it mean in terms of the vertical shift, guys? No need to worry that much. We are only talking about the upwards or the downwards shift. So it can move 1, 2, 3 or 1, 2, 3 in opposite directions. So if it's positive 2 there, then it shifts 1, 2. If it's 3 there, then it shifts 1, 3. If it's negative, then it shifts downwards by that particular whatever the number may be. So what I want you guys to notice with regards to the Q value is that the Q value, actually, we talk about the vertical shift. So let's say Q value has an impact on the vertical shift. And you know, when you talk about the vertical shift, you talk about the up or down movement. And again, if you have a value there of Q, which could be 1, 2, -1, or whatever number it may be, then it means the y-intercept in this case, the y-intercept, it is actually y being equals to let's say 1 plus q. So I'm just going to quickly explain that part of 1 over there. That's if, for example, over there you don't have a number. Maybe you have a function being y as equals to, let's say, 2 to the exponent x, maybe plus 2. So the y-intercept of this function is actually, you know that the y-intercept, that's where obviously x is equals to 0. So you substitute 0 there. What are you going to have? Anything to the exponent 0 is 1, which is that 1. Then plus, what is the q value? Whatever the q value is, which is 2 in this case, which means it is equals to 3. So that means on a Cartesian plane, you have 1, 2, 3. Then you are most likely to have your function something similar to that, and cutting the y-axis at 3. This is the x-axis. Very, very much important, ladies and gentlemen. So just make sure that you are aware of that type of information. But obviously, if this function, it was not just 2 to the x, maybe it had, let's say, 4 multiplied by 2 to the exponent, that plus 2. So that means it's actually 4 multiplied by 1, then you plus by 2, it becomes 6. Then it's no longer a 3. So I hope it makes sense, that part. So as part of your notes, I hope you added what I've written there with regards to that q value over there. So quickly, I'm going to plot a function of an exponential, just to give an idea of how it looks like. Remember, you just need to be aware of at what stage is that particular function. That's all that you need to know. And most importantly, have what is it? Let me just do yes, let me just leave it as it is. Have your Cartesian plane. Remember, I said in yesterday's lesson, a Cartesian plane is more like a plate where you contain food. So also this is our plate where we draw functions on. So maybe, let's say, let me draw this type of a function where maybe you've got y is equals to, let's say, 2 to the exponent x. Let me maybe call it a g of x. G of x being equals to 2 to the exponent that. So obviously, guys, you have, let's say, 1, 2, 3, 4, 5. -1, -2, -3, -4. You have 1, 2, 3, 4, 5, whatever. 1, 2, that, that. Very, very much important. So now let's sketch that one over there. Most importantly, guys, this q, again, I said this is the asymptote. So that means when it comes to hyperbola and exponential, in both of these you've got what we call asymptote. So for this one you don't have the vertical asymptote. Just like with a hyperbola, you had x is equals to something, then maybe x is equals to, let's say, 2. Then it becomes the vertical asymptote. So let me say in this case we don't have maybe the vertical asymptote, but we have the horizontal asymptote, and the horizontal asymptote is that. So for this one, which is g of x or y, it's equals to, let's say, 2 to the exponent x. Can you see q there? It's 0. So that means the asymptote is within that x axis. So that means my function is going to sondela that x axis. Why? Because the asymptote is within that x axis. So remember, guys, the first thing that you need to know is that where is your y-intercept. You know your y-intercept, that's where your x is equals to 0. So you're going to substitute 0 there, which means you are going to have 2 to the exponent 0, which is equals to 1. So that means your function is going to cut the y-axis at 1, which is that 1 over there. Then you can continue to substitute maybe 2 there. Let's say you're going to have 2 to the exponent 2, then the y value is what is it? Let me start with 1. So it's 2 to the exponent 1, then the y value is 2, which is 2 there. Then you just add it there to put 2 there and see what happens. When it's 2, that is 4. When it's 3, that is 8. So it just keeps on continuing. 8 up there. So you can see already that it gives you that shape. Just make sure that it doesn't touch, it doesn't cross, but at sondela that asymptote. So let's see, guys, what am I doing now? So now I'm on negative. So you say 2 to the exponent negative 1. So can you see when you say 2 to the exponent negative 1, it gives you half. So half is a positive value there. When you substitute maybe 2 to the exponent, let's say negative 2, it gives you quarter. So quarter is somewhere there below. So can you see, guys, now it gives you a very nice shape of a function, something similar to that. So this is the graph of y is equals to 2 to the exponent x. Massively important, guys. Let's quickly draw another function. So this one, guys, let's say it's actually, let's say y is equals to 2 maybe to the exponent 1, let's say plus 1. So let me call it let's say f of x. This one, that one, it was g of x. So this is the graph of g, and then this one, let's put the graph of f. So can you see, guys, this one is at that adult stage. So what is the a value, guys? The a value is that invisible 1 over there. That 2 is not a, but is b, because you can see it has the power of x. So that means there's invisible 1 and the b is 2 to the exponent x. So first thing first, you start with your asymptote. Can you see in this case your asymptote is now 1, which means you no longer have asymptote within that, but it's there crossing that 1 there, where y is equals to 1. I hope it makes sense, guys. Now you can substitute the values there. Maybe you can start with 0 there and see what happens. So obviously y-intercept, that's where x is equals to 0. Then you substitute 0 there. You're going to have 2 to the exponent 0, which is 1 plus 1 is 2. So that means your x-intercept is now, your y-intercept is going to be that. Then you substitute maybe 1 to see what is the y value. So it's going to be, I know it's going to be 2 to the exponent 1 is 2 plus 1 is 3. So that means where x is 1, y is 3, somewhere there. Then when you substitute 2, it's 2 to the exponent 2 is 4 plus 1 is 5. So 1, 2, 3, 4, 5. So where x is 2, y is 5. So can you see, guys, it gives you a very nice shape over there. But remember, it never crosses that. It just sondela, guys. Iqhubeka isondela duze or maduzana closer to the asymptote. What function is this? This is f of x. Very, very much important, ladies and gentlemen, that you fully understand all of that. Quickly, let me try to sketch a function. What type of a function can this be? Guys, I'm just not sure in terms of which function to plot in this case, or maybe which type can I plot, guys? I think I just want to check if I can maybe try draw something different. Okay, let me maybe plot y is equals to, let's say in this case is 3 to the exponent x, maybe a minus a 2 over there. Guys, I hope everything that I'm plotting over there is 100%. I hope so. So let's see. Obviously there, can you see you have -2 already? What does it mean? It means -1, -2. This is the asymptote for that one. So let's see. You now find the y-intercept where x is 0. So that means you're going to have 3 to the exponent 0 is always 1 minus 2 is -1. So that means you are going to have your function cutting there, which means possibly you are going to have that type of a shape. So this graph, let me call it h of x and say this is the graph of h. So the y-intercept is at -1, but the asymptote is that -2. I hope, ladies and gentlemen, that it makes perfect sense. So what I want you guys to notice is the impact of that vertical shift over there. So let's say, for example, I had to draw this function of y is equals to, let's say maybe 3 into 2 to the exponent x. Obviously the asymptote is within that, so that means in this case I'm going to have a 3 multiplied by into that. If I substitute 0 there to get the y-intercept, is going to be 3 multiplied by 1, which is going to be 3. So that means it's going to cut at 1, 2, 3. It's going to cut somewhere there. Maybe let's say I've got something similar to that as an example. And again, guys, what I do is just to change that a value. Maybe that a value for now, let me use a different number and say y, maybe it's equals to, let's say 2 to the exponent x. The question is, in this case, what is a? A is that invisible 1 there, but here a was 3. So you will find that obviously your y-intercept in this case is that invisible 1, because 0 there is 1 multiplied by 1 is 1. So it's going to cut there at 1. But now the difference is the steepness. Remember, we said A influence the steepness. So you might find that we've got something maybe similar to that. And again, let's plot the last one being maybe y is equals to, let's say half maybe 2 to the exponent x. So can you see the a value is half in this case, and we said half, or maybe we said a influence the steepness. So for that one, again, you will find that the y-intercept, obviously 0 there, so it's a half times 1 being half. So it's going to cut the y-intercept there, then eno rapalla le that thing. So in conclusion, we can say the bigger the a, the steeper the function. The smaller the a, the gentle the slope. So if you have a bigger a value, your function is going to be too steep. If you have a smaller a value, then your function maybe it's going to be less steep, which becomes gentle. So, ladies and gentlemen, that's all that I had for you guys in today's lesson, and I hope you enjoyed this lesson. So, guys, this brings us to the end of our lesson for today. Before I close this lesson, is there someone who's got a question, a comment, or whatever, guys? What was the lesson clear to everyone?
Yes, sir.
Guys, are you still there? Can you guys hear me, or is it the message which is still on the way?
Was very clear, say.
Someone says it was very clear. So, is it the same comment for everyone before I close, guys? I think I'm on 7% and I'm about to close. So, I just want to make sure that I don't close you guys outside. Okay, something very quick. Let me do this, guys. Let me do this just to confirm that we are clear. You can now all unmute your mic, guys. Just unmute your mic. When I ask a question, you can just give an answer. All of you, it's fine. You can now unmute your mic. Let's say we have y is equals to 2 over
I can see properly.
plus 2. Let's say minus 4. Another one, let's say we have y is equals to, let's say 2 multiplied by 3 to the exponent x, let's say plus 4. So here comes a question, guys. For this function, where will our function be? Where will it be drawn? Is it in which quadrants will our function be?
3 and 2. Quadrant number 1 and 3.
Because it is positive.
Quadrant 1 and 3, sir.
It's positive.
It's positive. What are the asymptotes for this one?
I can't see it.
Negative 4 and negative 2.
Yes, asymptotes, we have x being negative 2, y being negative 4. Nikala, click on the screen where you see the whiteboard. Don't have a list of learners what. Okay, so guys, in this case, what asymptotes are we having there?
Repeat again.
The asymptote for this function.
The asymptote of this function is it's positive 4 and
Okay, so guys, that was a quick question that I had for you guys, and it seems like you did understood the business of the day. So, ladies and gentlemen, have a very good night. In tomorrow's lesson, just make sure that you don't miss it. Attend, guys. You will definitely learn some new stuff. Guys, my name is Desmond, and I'm out.
Thank you, sir.
Thank you, sir.
Good night.
Thank you.
Thank you.